I'm going to run the code first and then try to explain what's going on here. First, I'm expressing this graph in Python, and then I'm gonna run two algorithms on it. First one is Dijkstra's algorithm. The second one is Bellman-ford's algorithm. They are both shortest path algorithm. When I run Dijkstra's algorithm on a graph with a negative weight cycle, as you see, it goes into an infinite loop. It will keep running forever. But if I run Bellman-ford, let's comment this out first. If I run Bellman-ford on this graph, this is the graph again, there is a negative weight cycle on it. If I run Bellman-ford on this graph, throws an error and it says graph contains a negative weight cycle. So what's really going on here? To explain this, I want to first give you a background story, like where we are and why are we talking about this. As we know, in computer science, we have graph theory, and under graph theory there are major problems that are being widely studied. One of them like route problems, network flow problems, visibility problems. We are here under route problems, under shortest path problems. We have several algorithms basically to find the shortest path among a graph. We have Dijkstra's algorithm. That was the first modern algorithm to find shortest path in a graph. And then due to its inability to handle negative weights, negative edges, Bellman-ford was developed on it. So here I'm going to show you how a negative weight cycle occurs step by step. As I just mentioned, we are going to be applying Bellman-ford on this graph. Again, this graph has a negative weight cycle on it. I'm gonna keep it short. Basically, we will be running Bellman-ford on this graph and we will have 3 iterations. I'm gonna run the first one quickly. We just relax the edges. 0 plus 40 is less than infinity, we update 2 as 40. 0 plus 50 is less than infinity, we update 4 as 50. 40 plus 50 is not less than 50, so we don't update here. We don't have update again. Here, 50 plus 30 is 50 plus 30 is less than infinity. We update 3 as 80. First sweep is over. I'm gonna jump to end of second sweep directly. And we have only one update there. That's over here. It's 80 plus minus 100 is less than 40. We update 2 as minus 20. I'm jumping to the end of third sweep. We have 2 updates here. Look. Minus 20 plus 50 is minus 20 plus 50 is less than 50. So we update 4 as 30. 30 plus 30 is less than 80. We update 3 as 60. Finally, in Bellman-ford, again, over here in the pseudocode, we have this check step. If there is an improvement in the graph after v minus 1 times, there must be a problem. There must be something wrong with this graph. That's how the algorithm works. And this is what happens here. After third iteration, there should be no improvement, but we still have improvement, even fifth iteration. It will keep running forever. To prevent this, Bellman-ford stops working and declares that there is a negative weight cycle in this graph and a correct solution cannot be found for this graph. I want to connect this point to quantitative finance. This is where arbitrage opportunity detection happens. Build a graph with it and then run Bellman-ford on it and then look for negative weight cycle on the graph. That's where the currency or any kind of arbitrage opportunity happens. Please let me know in the comments if I missed anything or if you wanna suggest new ideas how we can improve this project. Thanks for watching, guys. See you in the next one.